Hello, my name is Muhammad Zubair bin Bahar. In this video, we will discuss the example number 3 for the hydrostatic force. Okay, so the question given to us is determine the hydrostatic force due to water acting on the 1.2 meter by 2 meter rectangular area AB as shown. Alright, so AB, so probably you will see the A somewhere there, and that's the B. Okay, and you find the center of pressure measured vertically from the free surface. Okay, so the question asks us to determine, one is what is the F, and the second one is what is the HP, what is the value for the HP. Okay, so in example 2, all right, in example 2, we already discussed how we solve the problem by using the concept which I call the the concept state that we are using the vertical, all right, the vertical, all right. So on the example, all right, example 2, we use vertical method, all right, vertical method. So okay, so in this example, we try to solve it in terms of the y method, all right, the y method. So in order to create a y method, first of all, you need to extend, all right, the body of this plate AB here until across the free surface. Okay, so I draw it here, but actually when you try to answer this, you need to redraw the free body diagram. Okay, so since I want to show it to you, okay, so I use this figure here, all right, and draw a dotted line, all right, and then until it cross the free surface. But sir, there is no free surface at the end. Yeah, there is no water at the end there, but what you need to do is just like you try to extend, all right, also the fluid, all right, the free surface, even though the free surface is not there, all right, you just extend it here. All right, when after you extend it, and then you see the cross somewhere here, and then you draw a line, all right, a line which is perpendicular to the line, the red dotted line. Okay, so this we call the OX, which is a 90-degree there. Okay, and once again, after doing that, next what you need to do is to what we call put a point, all right, the point CG, point CP. Okay, so we start with the CG. So CG is somewhere in the middle here, all right. So let's say that the CG, all right, call this as the CG, if you can see that. Okay, and this line here, okay, call it as the y bar. Okay, call it as the y bar. I think I need to make it much bigger for it to see. Okay, and then you know the point of CP. All right, the point of CP is somewhere at the bottom. All right, so this is a point of CP. Write it CP. Over here is CG. Okay, and the distance from here, all right, from the CP to the line OX. Okay, so you call this as the YCP. Okay, at the point CP, at the point CP is where the force act. Okay, so draw a force F, make it bigger, a big arrow, all right, for easy for you to see it. All right, write it as the F. Okay, and the distance is YCP. Okay, but all right, but in the question given to us, they are looking for HCP. We will find the YCP and we change it into the HCP. Okay, so this is the free body diagram, which is very important for you to draw it clearly. All right, so draw it, make it bigger for you to see it. All right, for you to see it. Okay, so now from all right, from the diagram that we have here, all right, so it is clear that, all right, it is clear that your y bar here, y bar is the combination of, all right, combination of half of this body, all right, half of this body, which is 1.2 divided by 2, and plus another distance here, all right, and that distance we call it as a y. So from there you know that the y, all right, the y bar is equal to y plus 1.2 divided by 2. All right, is it clear? Okay, so now if everything is in order, then of course you will see the f is equal to rho g your y bar sine theta time a, and then you know the rho g actually is 9810 because it's water. What is y bar? Y bar is equal to 1.1.2 divided by 2, and then plus the y, all right, plus the y there. And if I can draw at the top here, all right, draw at the top. Okay, this is a 2 meter, and then this is theta. Of course, there will be theta, then it is 90 degree, and then this is y. Okay, and clearly y is equal to, how much is that? 2 divided by sine 30 degree. Okay, so sine 30 degree is almost like 4 meter. All right, so the y actually is 4 meter, and then put back into the equation, you got 4 there. Okay, and then rho g y bar, okay, we have a y bar, and then sine, all right, sine 30 degree, and time the area, which is 1.2, and time 2 meter, all right, time 2 meter. Okay, if you do the calculation, and finally you see f is equal to 54.2 kilonewton. You get the same answer as in the example 2, because it is the same plate, or this the same plate, all right, on the same place, and on the same everything are just the same. All right, so the only difference is the way we determine the force. All right, this time we are using the y method, not the vertical method. Okay, all right, so now we are looking for HCP. All right, we are looking for the HCP, and you know that the HCP, all right, is equal to what do you call it, as the YCP sine theta. Is that right? Because that the relationship between the y and h. Okay, so if you want to know the HCP, you can find it by using the YCP. Is that right? So YCP by definition is equal to y bar plus the ICC, and there is no sign when we use this y, and divided by y bar a. Okay, and this y bar is known there. Okay, 4 plus 1.2 for 4.6. Okay, so you have a y bar plus the ICC. What is the ICC? ICC for this rectangular, which is a BH cube, and then divide by 12. All right, divide by 12. Divide by 12, and then you have the y bar again. All right, you have the y bar and time the area. The area of the rectangular, we can say it as the base time the height. Is right? Okay, it is the base time the height, and then you know this. This is a base. This is also the base, the same base, and we have the height. It is also the height, so power of 2. So left you with the y bar plus the h power of 2 divided by 12 y bar. Okay, so what is the value of h in this case? Okay, if you want to know what is the h, you see the line OX here, the blue line here. Okay, now you want to transfer it. You transfer to the center of this body. Of course, it will cross the 1 point. cross 1.2. So H is 1.2. Alright, it cut the 1.2, which we call it the rich guy. Alright, the rich guy. Okay, so y bar is equal to 4.6 and then plus your 1.2 square and then divided by 12 and then you have your y bar again 4.6. Okay, and from there, okay, if we do the calculation, we try again here, 1.2 square and then divide by 12 and then divide by 4.6. All right, and then plus 4.6. Okay, what we have here is 4.62. Okay, so where should I write it here? Okay, I write it here. Okay, so your YCP is equal to how much is that? 4.6 3 meter. All right, so YCP is 4.36 meter. Okay, so if we go back to the equation here, all right, the green one here, and we know that the HCP, all right, HCP is equal to YCP sine the 30. All right, when you sine the 30, finally you got the SCP is equal to 2 point, let me see, okay, and then the time the sine 30 there, okay, and all right, you got 2.313, exactly the same as in the example number 2. All right, so the question is why we need to repeat the same example again. All right, so I ask you to try both method. All right, try both method. One is the vertical, the other one is in y direction. Okay, you need to feel it. All right, you need to feel it. Which one is more comfortable to you, whether it is the vertical or you want to use the y. All right, some people, the way they think, they can only see on the vertical, they cannot see on the slanting here. All right, but some said the y direction is much easier compared to the vertical direction. So that's the reason why use the example 2 and example 3, all right, for you to try yourself, all right, and try to determine which method is familiar or you're feeling good about it, okay, and use that method every time. And once again, I like to remind you again, whenever you use the y direction, there is no h in your free body diagram. All right, no h in your free body diagram. And whenever you use the vertical method, so there is no y in your free body diagram. You get it? Okay, so you must separate that too. If you want to use the vertical, everything is in h. If you want to do the y direction, everything must be in y. Don't combine, because when you combine both of it, it will make you, all right, feel fluid mechanics is so hard. All right, so I think we better stop here and we will see again in example number 4.